Hello everyone, hope you guys are doing well. In this video, I'm going to explain mock exam for PA term of spring 2024. So the question 1 is asking us to find the molar ratio between sodium carbonate and a water in a hydrated sodium carbonate, which is shown in here. We can see that sodium carbonate, CO3, with the water, they made a compound, but there's 10 of them, 10 water. But we know that the 1 in here is the molar ratio, mole amount of sodium carbonate, and the 10 is the mole amount of water. So the ratio would be 1 to 10. That's why the answer is C. Now, second question is asking, determine the mole of oxygen atoms are in 2 moles of this, okay? So we know that in 1 mole, I have altogether, I have 3 mole oxygen coming from here and 10 over here, so altogether it is 13. Now this is for just 1 mole of this hydrate. If I have 2 mole of those, I will have 26 mole of oxygen atoms. So that's why the answer is going to be 26. Question 3. It is asking us to find whether the statement is true or false. In the first one, it says mass of 1 mole of substance is a molar mass. It is correct. We know that 1 mole of any the mass is going to be molar mass. Now the second question is said 1 mole of any gas at room temperature is 22.4 liters. This is incorrect because at room temperature 1 mole is 24 liters. At STP it is 22.4 liters. Now it says compare the volume of 24.08 times 10 to the power of atoms of CO2, the same amount of atoms for H2. Now first thing we need to realize that we got here the exact same number of atoms, right? So as soon as we see these numbers, we're going to divide it by Avogadro number to convert it to number of moles. So we do this, and if you use the calculator, you're going to see that it gives you 4 moles. Now we have 4 moles of atoms for CO2, 4 moles, and we have 4 moles for H2. But these are atoms, not the molecules, so we need to convert them to moles. Since CO2 is made from 1 carbon and 2 oxygen, there are 3 atoms. So these 3 atoms, 3 mole of atoms, they give you 1 mole of CO2 molecules. On the other hand, when you have 4 mole of hydrogen atoms, we know that 2 mole of hydrogen atoms, they come together and give you 1 mole of H2 molecules. Now we need to convert them into the molecules, the numbers we got in here for the atoms, and that we're going to do using the proportion. So we know that 4 mole of CO2 atoms, which means altogether carbon and oxygen, give you X mole of CO2 molecules. And we know that 3 mole of CO2 atoms, meaning carbon and oxygen separately, they come together and give you 1 mole of CO2 molecule. Now we're going to do a cross multiplication. This will give us that we have 4 over 3 mole of CO2 molecules. Now in here it is not stating whether it is at room temperature or standard temperature and pressure, so we can choose either one. Let's choose room temperature in here, meaning that 1 mole is 24 liters. So 1 mole of any gas is going to be 24 liters, right? So if I have 4 over 3 mole, which I found above here, will give me X liters. And I do cross multiplication to get the answer, which gives me X equals to 32 liters of CO2. Now this is the volume for CO2. We're going to do the exact same thing for hydrogen. We know that 2 mole of hydrogen atoms make 1 molecule of H2, right? So 2 mole of hydrogen atoms that come together give you 1 mole of H2 molecule, right? Molecules. So we were given that we have 4 mole of H atoms, so it would be X mole of H2 molecules. So you do cross multiplication here again, and you would get that there is 2 mole of H2 molecules. Again, we're going to try to convert it to liters, which is the same thing as we did in here. So we know that 1 mole of any gas is 24 liter. This is the room temperature, and we have 2 mole of H2. It is X liters. We do cross multiplication, we get the X to be 48 liters. As you see in here, we got CO2 less than H2. That's why we can compare their volumes in this fashion. But in general, I wanted to tell you, let's say you're given H2SO4. Let me give you C4H10 and CH4 in this case, okay? So let's say you're given their amount of atoms, okay? Number of atoms is given to be 1204 times 10 to the power 24, 1 times 204 times 10 to the power 24, and you want to compare their volumes, right? Volume. And we say this is 1, this is V2. We know that we always, because their number of atoms is the same, we need to divide it by the total number of atoms. We know that C4H10 will be divided by 14, while CH4 is going to be divided by 5. So because when we divide it by 5, it will give us higher volume, V2 will be higher than V1. So when you have more atoms, you will have less volume. When you have less atoms, you will have bigger volume, considering that you have exact same number of atoms. Okay, now we are moving to question 5. In question 5, we're given B-chlor2. This is a compound. Now, even from here, B-chlor2, we can see that the valency, we know that the chlorine is a group 7, so valency of it is 1, and the B is going to be 2, just so you have an idea. And there's a key information here. It is talking about molecules. Now, as soon as you give molecules, you can relax because it's going to be easier this time. You don't need to convert the atoms into molecules as we did above and here. So what we need to do, we need to find the mole of this amount, and we're given the number of grams in here for corresponding number of moles. So N would be in here the number of moles. I'm going to say number of moles will be just 1.806 times 10 to the power 24 divided by Avogadro number, and this gives you 3 moles. Now we can see that 3 moles of B-chlor2 is 333 grams. Now we need to find 1 mole of it because we need the molar mass. And this, if you do the cross multiplication, you're going to get here 111 grams. Now, you can see from the periodic table that atomic mass of chlor, it is 35.5 gram per mole. So because we have 2 of them, we do 2 times 35.5 plus the molar mass of B equals to 111 grams, right? Now, from here, we can do the calculation. We will see that 111 minus 2 times 35.5 gives you 40 gram. And if you check the periodic table, it corresponds to calcium. Calcium is a 2A group. It also matches with its valency. And that's the answer. Now, the next thing we need to move on into I'm going to move on to question about combustion, and then I'm going to come back to the other question again. So this is the combustion reaction, question 12. Later on, I will come back to question 6 because this one is easier than the other question. So C8H18, it says that it burns. We know that for burning, we need to have oxygen, and it releases carbon dioxide and a water. So we have CO2 and a water coming out. Combustion reactions are always like this. Oxygen plus CO2 and water is the product. Now, for C8, we know that we have 8 carbons here. So I'm going to multiply this by 8. And then I have 18 hydrogens, so I'm going to do it by 9 to get the carbons and hydrogens. I always leave the oxygen to the last. I can see from here that 8 multiplied by 2, I get here 16 oxygens, right? And I have here 9 oxygens. These are oxygens. When I add them up together, it is 25 oxygens that I have. And I have only 2 in here. In order for me to get this, I need to multiply this by 25 over 2, right? But we know that we can't have a fraction, so in order to get rid of it, I will multiply everything by 2. Now, everything by 2 means I'm going to do 2 here, and this one will become 25, this will become 16, so this one becomes 16, while the other one in here is going to become 18. Now the reaction is balanced. The next thing it is asking us to calculate the mass of octane needed to produce 44 grams of carbon dioxide. Now carbon dioxide here, so what I recommend you to do is to actually find the molar mass of CO2. Now if you check the periodic table, you will see the carbon is 12, hydrogen is 1, and oxygen is 16. So when we do this, we get 44 grams per mole for this one, right? So we will write everything we know underneath. So I have 16 of this, so I'm going to write 16 times 44. And the other thing is asking about is the octane. Octane is this guy, right? C8H18. Now we need to find the molar mass of C8H18, which is 8 times 12 plus 18 times 1. And this would be 96 plus 18, which is 114. So because I have 2 of them, I'm going to write 2 times 114 grams. Okay, so these are grams. And now it is telling us, what if you produce 44 grams of this? How many grams of this you need? How many grams of this you need? So we write here x. We're going to do cross multiplication. So this would be x times 16 times 44 equals to 2 times 114 times 44. Now, what we do, we're going to cancel out 44s on the both sides. X would equal to 2 times 114 divided by 16, and you need to be getting from here 14.25 grams of C8H18. And that's the answer. Now, once we did that, we're going to go back to here to question 6. Now, in question 6, it is talking about benzene. Benzene is the product here, right? It tells us to, first of all, balance the reaction. When we balance it, we say that we have 2 carbons here. We have 2 carbons. Calcium, we have 1, so calcium and carbons are good. But we have 2 oxygens here, but 1 oxygen here. So if I put 2 in here, my hydrogens is also going to be okay because I have 4 here, 2 and 2 here, altogether 4. Now everything is balanced in the first reaction. The second reaction, I'm going to just put 3 in here and everything is good. So this one will be just transferred here. Now the next thing it is asking us to calculate the mass of benzene produced from 18 grams of H2O used. So look at here, we have 18 grams of water. I'm going to write this stuff that is given to me. 18 grams on the top. And they're asking us how much of this is needed. So I'm going to write here X gram. So that's what they're asking. Now, the trick I'm going to tell you guys is going to be applied here. So Once we balance the reaction, we're just going to copy it down here. I have 2H2O, and it makes us C2H2, and then calcium hydroxide. And then we have here 3C2H2, giving you C6H6. Now the trick I will tell you is, do you see that I have here 3C, which I got from here, right? So what I'm gonna do, I'm gonna multiply everything by 3 on the top part so I can have 3CH2 here as well, okay? So when I multiply it, it will be 3, this will be just 6, this will be 3 and 3. Now, as in math, you can add up the chemical reactions. So when we add it, we have 3 calcium carbide plus 6 water plus 3C2H2, and giving you 3C2H2, 3 calcium hydroxide, and C6H6. But the thing is, as we know in the math, if we have the same thing, it's like an equal sign. We have the same thing on both sides, they cancel out. So you have this reaction, 3C2 plus 6H2O, giving you 3 calcium hydroxide and C6H6. Now, let's look at the question. It says 18 grams of water, right? So we're going to write the 18 grams of water here. And it's asking us how much we need this one, right? Now, all we need to do is write underneath the molar masses. If you check out the molar mass of water, H2O, hydrogen is 1, so 2 times 1 plus 16 times 1, which is 18 gram per mole. So because I have 6 in here, I'm going to write 6 times 18. And it's asking about C6H6. I will find the molar mass of C6H6, C6H6, and this is 6 times 12 plus 6 times 1, and this is 78 gram per mole. So I'm going to write underneath just 78 gram, because there's only one, right? Now we just do cross multiplication, and x is going to equal to, so 78 multiplied by 18 divided by 6 times 18. Now, if you will do cancel out the stuff that we have in common, 18 and 18, and you will get the answer, 13 gram of C6H6 will be made. That is the answer. So the only thing that we did in here is differently, is that we got the same values, same number of C2H2 in both, and then I added everything up. And I set up a new proportion between the water and benzene. Okay, now it's asking us now to calculate the mass of benzene that is produced from 128 grams of calcium carbide. We use the same equation that we derived in here, this one. So I'm going to write 3 calcium carbide plus 6 water, giving me 3 calcium hydroxide and C6H6. So 128 grams of calcium carbide, right? So this is the stuff that is being asked from me, and it's asking me how many grams of benzene will be produced. In this case, again, we need to find the molar mass of calcium carbide, which is 40 plus 2 times 12, which is 64. 3 times 64 grams, and then C6H6, if you find the molar mass, which we did above, it is 78. Again, we're going to set up the proportion, x equals to 78 times 128 divided by 3 times 64. If you cancel out certain things, which will give you 2 up here, and then 78 and 3 will cancel out, this gives you 26, so altogether it would be 52 gram of C6H6. That is your answer. Now, that being said, we're moving into the question 7. It says magnesium chloride is a compound used in medicine. It gives you info about the magnesium. Magnesium, if you check out, it is a 2A group Chloride, you will check out, it is 7A group. We know that to complete the octet, magnesium will lose 2 electrons, which will make it a valency 2, and 7A group needs 1 electron to complete the octet, which is why the valency is 1. It says write down the chemical formula of this compound. So magnesium here, chlorine here, so I put 2 and 1, crisscross, so it will turn into magnesium chlor 2. And the type of bonding, we know that it is a metal, and this one is a non-metal, so the bonding type will be ionic bonding. That's it. It says draw the dot cross diagram for magnesium chloride. So again, because it is ionic and I have magnesium, so magnesium we start with 2 electrons on it. So I'm going to write here 1, 2. Well, the chlorine, because I have 2 chlorines, right? So I'm going to write chlorine here, and it has 7 valence electrons. So 1, 2, 3, 4, 5, 6, and 7. And then we're going to draw another chlorine here. 1, 2, 3, 4, 5, 6, and 7. Now, we know that this electron in here will transfer to here, and this will transfer to here because it is an ionic bonding, right? And the final product would be like this. So we got magnesium, chlorine, and so magnesium in the center, it will be +2 because it lost the electrons. Chlorine would be on both sides, negative and negative, and they will have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and those 2 electrons will go to each one in chlorine. And that's what you have for ionic bonding. We know that in ionic bonding, it's never like a Venn diagram like this. Okay, don't do that. It is actually separate. Now we're going to go to question 8. So we have X, Y, Z in here. It says the electronegativity is at 3, 1, 2, 3, 5. Okay, so it says that to determine the bonding type and the formula of a compound formed between X and Y. X is a group 1, which means the valency is going to be 1. Y is a group 16. It's in the other term. It is 6A, so the valency is going to be 2 because it needs 2 electrons to complete the octet. Now 2 will come to the bottom, crisscross, and it will be X2Y. It says draw the dot cross diagram for the compound formed between X and Y. Justify your answer for bond formation. Now, when we check the X and Y, we can see that their electronegativity difference is 1.8. Exactly 1.8 or more than 1.8 is going to be ionic bonding. Ionic bonding. Also, from the group numbers, you can see that this one, X in here is a metal, and Y group in here is a non-metal. Okay. Now it says we already justified the bonding by using electronegativity, so we got that. And then it says draw the dot cross diagram. So because it's an ionic bonding, I have 2 of the X's, so I'm gonna do in here X, so I'll put in here and I will put Y into the middle, and I put X in here as well. So because X lost the 1 electron, it only had 1 valence electron, it is a plus, while Y had 1, 2, 3, 4, 5, 6, and it took the electrons from X, so this one in here, this one in here, and then this is the Y with -2 in here. Okay, so that is the ionic bonding. It says Z can form a diatomic gaseous molecule. It has 6 valence electrons. Now Z diatomic means Z2. Okay, and it has 6 valence electron. So if it does the diatomic gaseous molecule, we know that it is non-polar, polar covalent, right? And that means we're going to have a Venn diagram. So 1 and then 2, and then we have another one, Z here. So they start with 1, 2, 3, 4, and then 1, 2, 3, 4, and I'm going to put their sharing electrons sorry, I'm going to do the other one with crosses so you can see the differentiation. And we're going to put 1, 2, 1, 2 like this. You would see that I have complete octet here, and I have completed the octet here. This is just a like O2 molecule. And in here we have 1 sigma and 1 pi, because we know that the first bond is sigma, the second bond is the pi. The valency of the Z atom is going to be 2, because it's like this, Z, 2 bonds in this case. Whenever the valency is the number of bonds it has. Because Z has 2 bonds, the valency is going to be 2, and the valency of this one is also going to be 2. The number of bonds indicate what's the valency. For example, if I have a water molecule in here, I know that the valency of oxygen is 2, and the valency of each hydrogen is 1, because they have 1 bond each. Now, in the third part, it says it's known that the YZ molecule can form ionic bonding. Considering this information list, at least list 4 physical properties that can have YZ molecule. Now, one of them is they are always solid. They have high melting point and boiling point. And then you can say that they are soluble in water or polar solvents. So water has a polar covalent bond, right? So it is soluble in other polar solvents as well. And then you can say that conduct electricity when dissolved in water, or melted. When it's melted, you can say this. Also, you can say it has a crystallic structure. So all this stuff is going to be the physical properties of the ionic bonding. Now, in this question, X and Y, it says that it is an ionic bond. YZ2 compound has a covalent bond. Now, we know that ionic bond happens between a metal and a non-metal, right? While covalent happens only between the metals, non-metals. So we know that Y and Z are non-metals right away. And we know that in here, either Y or X gotta be non-metal. So we already know that in X and Y is a ionic bonding. So X is gonna be metal because we defined the Y to be non-metal. So that's what you have. YZ is gonna be non-metals. X is gonna be the metal. Now, I'm going to come back to the question 10 after I do the dot cross diagram of ammonium hydroxide. But before I do this, I'm going to do question 11 for you. Now, in question 11, we're given the number of sigma pi bonds. So right away, I'm going to tell you that because we don't have a double bond, there is 0 pi bonds. This is straight up. And then we're just going to count literally the number of bonds we have and say that it is the number of sigma bonds because they are all single. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that means we have 17 sigma bonds. Okay, now hybridization type. A lot of you are getting worried about the hybridization. I'm going to tell you literally the easiest way to know this. When you have carbon with 4 single bonds, meaning 4 sigma bonds, the hybridization is sp3. And the molecular geometry of this is going to be called tetrahedral. Okay? And that's it. Now, because we have only carbons with single bonds in here, all of the carbons, all of them, will have the molecular geometry of tetrahedral. And because they will all are single bonds, all of their hybridization is sp3, and that's it. Now I'm going to tell you about the other type of hybridization. There's two more. So when I have a carbon with one double bond and and two single bonds, in this case I have 3 sigma and 1 pi, right? The hybridization in this case is sp2, and the shape molecular geometry is trigonal planar. And I'm going to tell you the last one. It is carbon with triple bond and a single bond. In this case, I have 2 sigma and 2 pi, which means I have hybridization of sp, and the molecular geometry in here is called linear. And that's it. All you need to do is to know this information. Okay? Now, that being said, we're going to do the question 13, and I'm going to finish off with the last question 14. Okay? So question 13, it's asking us to draw the dot cross diagram for ammonium hydroxide. Ammonium hydroxide, ammonium ion, you need to guys know by heart. This is the ammonium ion. Hydroxide, it is OH negative. Sometimes they can write the different compounds, like ammonium bromide, for example, ammonium bromide. Now, this one, right away we can see that ammonium is here, NH4, and then bromide is brom negative, because it's a 7A group, right? Now, it's telling you to draw the dot cross diagram for this. I want to show you, first of all, where it is coming from. It is coming from NH3 plus water. Now, this is not something that you need to know, but I want to show you how this happens. So NH3, if you guys remember, the dot cross diagram of NH3 was nitrogen in the center with 2 electrons here, and then we had, I'm going to draw it a bigger picture. So we had nitrogen and then hydrogens. So, and then we had for the water, I'm going to draw it like this. I drew the oxygen in a smaller circle. Okay, so I have here nitrogen, hydrogen, hydrogen, oxygen, hydrogen, and hydrogen. Now we know that nitrogen had 2 electrons and 5 electrons in general, and there's one more hydrogen here. So one more hydrogen. So nitrogen had 5 electrons, 2 of them it's shared. There is one more hydrogen here, and hydrogen brings together with them an electron, and that's what we have, right? While the oxygen in here had 6 electrons to begin with, and the hydrogen brings 1 each, and oxygen puts the electrons like this. This is what we had, right? We have done it multiple times with you. Now, when these two things react, they actually give you ammonium hydroxide, which is NH4 and OH. So if you guys remember, we already did NH4, right? Now, in this case, the hydrogen that you see over here, one of them, for example, is gonna transfer from here to the nitrogen. And the nitrogen is gonna donate these 2 electrons it has, donate these 2 electrons to the hydrogen. So the way it happens, nitrogen is gonna go to the center. So let's write it here. So 1, 2, 3, 4, and 5. So it kind of went small, but let's try to manage with this. So hydrogen, nitrogen, hydrogen, hydrogen, and hydrogen. So 2 of the electrons, they were here, right? These ones were polar covalent bonds that we had. Now then this hydrogen, the other hydrogen, came without the electron, meaning that nitrogen donated both of its electrons to here, and that's what we had for ammonium, right? Plus. While these 2 electrons in here, they're still there on the oxygen because hydrogen left out without the electrons, right? Now this is how it looks like. So oxygen, oh, I'm gonna write it in a bigger letter. So in here we have oxygen inside this, and then we have oxygen in here had this electrons 1 2, and then 1 2 in here. I'm just drawing the picture that we had there, and this 1 and 2, the hydrogen's electron left out here. Now in this case, so oxygen also had this. In this case, we have left the structure where this is the negative, this is the positive in here. Okay, ammonium hydroxide. Ammonium hydroxide. Now, because it is positive and negative here, positive and negative, they are pulling each other, right? We have here ionic bonding. Ionic bonding between them. We also have polar covalent inside ammonium, and we also have coordinate covalent inside ammonium. And here in the OH we have also another, I'm going to color them in the same color, so polar covalent. So all the purple ones, and then we have this brownish color. So purple ones are polar covalent bonds, covalent. The one in the brown is coordinate covalent, which we did many times for NH4. And the ionic bonding is the red one. So ionic bonding, I showed you here, is the red one. So altogether, we had both ionic bonding and covalent bonding there. Now that's why after this we're gonna do the other question we left up there. For example, let's do it for ammonium bromide. Ammonium bromide. I know that I'm just gonna draw the exact same thing for ammonium. Do we agree? So I'm not gonna draw you the exact same picture. I'm just gonna literally grab this. So ammonium bromide, I wanna do it. So let's see. Over here, let me just clean around it. So I'm gonna ammonium bromide we have. So this is the ammonium part of it. And the bromine itself, bromine, is gonna be just a circle, bromine here, because the bromine in the beginning, it started with 7 electrons, it's a 7A group, and then it took one more electron from the hydrogen. And that's it. This is the negative, and this is the positive. Now this is ammonium bromide, NH4 brom. Now we again have ionic bonding between these two. So I'm gonna write it here, and we have polar covalent ones in the purple, and then the brown one is coordinate covalent, and bromine by itself, like there is no bond in here. Okay, so we have 3 polar covalent, 1 coordinate covalent, and 1 ionic bonding. Okay, so that's what we have for ammonium bromide. Now I'm gonna tell you the question in here. So metallic we didn't really cover, but when you see a metal, you know that it is the metallic bond. Only ionic bonding, we know that only ionic happens between the metal and non-metal, and this is the one we have. So E is here. It says only polar covalent. Now we know that this is non-polar covalent. Polar covalent happens between the different non-metals, so we have here B, and we also have here F, because hydrochloric acid, also different type of non-metals, right? And it says non-polar covalent, we know that it is C, because brom2 is only made from brom, and electronegativity difference is 0. And ionic and covalent, as you see here, it happened between ammonium and nitrate. Now ammonium and NO3 negative, they are pulling each other. This is ionic bonding. But inside here, we know that it has polar covalent and coordinate covalent. Also, this one has inside polar covalent, because they are non-metals, right? There's, in here we have made from non-metals, and this is also made from non-metals. Now that's why this is gonna be D. Okay. Okay, so now we're gonna do question 14, and we're gonna wrap this up. So in here we're talking about pyrit, which is a compound between iron and sulfur. It states that the step 1, 2, 3, it happens like this, and we get the SO2 in here. That SO2 comes into contact with oxygen. We get the SO3, and then SO3 reacts with water. So there are 3 steps for this reaction. So stoichiometry in 3 steps, that's what we need to deal with, okay? First of all, it says balance the step 2 and step 3. So it's a simple thing. So because you have 3 oxygens here, you're going to multiply this by 2, and you will multiply this by 2, and you get the balanced reaction. And then in the bottom one, you would see that there's actually no need to balance. Everything is balanced. So that's what you have for the A part. Now, in the second part, it says calculate the mass of pyrit required to produce 49 grams of sulfuric acid. Okay, so 49 grams of sulfuric acid. We know that sulfuric acid is in here, and we're just going to write on the top what is they're giving us, right? The condition, and they're asking us to find mass of pyrit required, right? Which is the X gram in here. As you see, we need to relate these equations to each other. Now, again, the way I'm going to show you, it will make your life super easy. Once you balance this and wrote this reaction into here, we will do like this. So you see that we have the connection in here is the SO2, right? The SO2 comes and goes here, and then SO3 comes and it goes into the reaction. So we need to make sure we have exact same numbers in front of them, meaning in here we have 8, right? I want to also have 8 in here. So what I need to do, I'm just going to multiply the second equation by 4, the balanced reaction. So when I multiply by 4, this 2 becomes 8. So I'm going to delete it. This 2 becomes 8. And then this 1 becomes 4. And this 2 becomes 8 again. And then in the bottom, I have, you see, I have 8 in here. So I'm going to multiply this by 8. So everything is 8. Now, in this case, we're going to again, add them up as in a math equation. We're adding the equations, okay? So when I add it up, I'm going to write 4 of S pyrit. I have 11 oxygens. I have 4 oxygens. I have 8 SO2. I have 8 SO3. And I have 8 water. 8 water, that's what I have, right? In this left side. And on the right side, I got 2 iron 2O3, and then I have 8 SO2, I have 8 SO3, and I have H2SO4. Now, again, we need to cancel out the same thing on the both sides. So we have the same thing on both sides, so we're going to cancel this and this and this. Now, in the end, what you have, the reaction is 4 of pyrit, and then we have in here 15 of the water, right? 15 of oxygen, and we have 8 water. It's given us, I forgot that there was 8 of this H2SO4, so O3 and then 8 H2SO4. Now this is our balanced reaction. Now things are much more simpler. We have 49 gram of this. It's asking us the gram of that, right? All we need to do is put their molar mass. Now this one can be rounded up to 120, right? Approximately. So I have 4 of them, so I'm going to do 4 times 120. And then we have H2SO4. You need to check out the periodic table. of H2SO4. Hydrogen is 1, so 2 times 1 plus sulfur is 32, and oxygen is 16, so 4 times 16, you get here 98 gram per mole. So you're going to write here 8 times 98 gram. This is gram. And then you do cross multiplication. So it would be x times 8 times 98 equals to 49 times 4 times 120. And then you're going to just simplify it. 49 420 divided by 8 times 98. And then from here you can cancel out the common things. So we got here, so we have 2 in the bottom. And then over here we do that, and then we get to 2 in the bottom. So it would be 120 divided by 4, which is 30 grams. Okay, so that is the answer we got. Now, the bottom one, it's asking us calculate the liters of oxygen at STP. STP, we know that STP is 22.4 liters, right? So, but the portion that we need to be careful is, look at here, it says required to burn pyrit. Okay, pyrit in here is this one, and we need 11 of this oxygens. We had here 11 oxygens and 4 oxygens. Now this 11 ones are the ones to burn the pyrit itself. So we're gonna use that. Okay, so we will write that equation, the one on the top. So 4 F2 and then 11 oxygens and 4 oxygens, and then we have in here 8 water, and then it gives us 2 of the iron 2O3, and then 8 H2SO4. Now in this case, as you see, I summed them up in here in the second portion because I didn't need the oxygen. But this time it's asking us to burn the pyrit. Okay, so to burn the pyrit, I know that I need 11 times 22.4 liters as in the equation, and here I have 8 times 98 grams. These are the molar masses. This is the stuff that I know. And it's asking us to find the x liters in here, and it tells us what if you're given 198 gram of this. So again, you do cross multiplication. X would be equal to 198 multiply 11 times 22.4 divided by 8 times 98. Now this one was 96. I made the mistake. So this is 96. We know that in here 196 and 98 canceled out. Like, you will use the calculators, you won't need this, but it would be 2 times 11 times 22.4 divided by 8, and then the answer will be given to you, and I will do it right away on my calculator, which will be 61.6 liters. Now this question, if it's difficult for you, don't worry about it. Like, this is not going to be like a something, the level that you will be tested, because it might confuse you with the oxygen levels. If you're good till this part, you should be okay for your PA exam. Okay, I hope this helped, guys. I tried to cover everything. Please review the video and just stop whenever you feel like struggling, and then do it on your own, and then come back to the video again. Good luck to you. I'll see you tomorrow.